Hey guys, today we're going to talk about solving quadratic equations, and a quadratic equation is any one with a degree of 2. So it's going to be in the form ax squared plus bx plus c equals 0. A cannot be 0 because if a is 0, then it's a degree of 1. Okay, so we're going to solve in 3 different ways. Those ways that we're going to solve are by factoring, completing the square, and the quadratic formula. So we'll start by factoring. Typically, factoring is going to be the easiest of the methods. Unfortunately, some equations are just unfactorable, or at least they can't be done nicely. So sometimes it won't really be practical, but if factoring is possible, then it's the way to go. So we've got 4 different types of factoring equations that we're going to deal with. The first one, I'm going to factor out the greatest common factor. There are only 2 terms. In this case, c is 0, so we've got an x squared and an x term, and an x can be pulled out of both of those. So I'm going to factor out that x, and we'll have x times 2x minus 7 equals 0. Okay, so I'm going to have 2 solutions, or 2 roots, and those roots are what value of x makes each factor a 0. So if I put in a 0 for the x's, this first factor is going to be 0. So one of my roots is x equals 0. The other root is the value of x when this second factor equals 0. 2x minus 7 set equal to 0. I move that 7 over, it becomes positive, and divide by 2, I get x equals 7 over 2. Those are my 2 roots, 0 and 7 halves. In B, the first thing I want to look for is whether or not there's anything I can factor out of all 3 terms like I did here. I factored out the x, and in this case there's nothing that can be factored out of all 3 terms. So we're going to factor this one into a pair of binomials. So that means we need a pair of numbers that multiply to negative 63 and add up to 2. Now we commonly think of this number right here, this negative 63, coming from the fact that c is negative 63. But it's actually not only that c is negative 63, but also that a is 1. And a times c is negative 63. And so when that lead coefficient is 1, it is just c, but it's because 1 times c is c. Sometimes that'll be different if the lead coefficient is not 1. So 2 numbers that multiply to negative 63 and add up to 3, those 2 numbers are going to be 9 and negative 7. 9 times negative 7 and 9 plus negative 7. Multiply and add where we need them to be. So we're going to have x plus 9 times x minus 7 as our 2 factors. What value of x makes this factor a 0? That's going to be negative 9. Negative 9 plus 9 is 0, so x equals negative 9. And what value of x makes this factor equal 0? That would be 7. So our 2 roots are negative 9 and 7. So each of these first 2 cross the x-axis twice at 0 and 7 halves, and then at negative 9 and 7. Okay, C, once again, the first thing I'm looking for is whether or not there's anything that can be factored out of all 3 terms on the left side. And I can't factor out an x, but I can factor a 3 out of all 3 terms. So I'm going to pull out that 3, and I'll be left with x squared plus 8x minus 33. Okay, so now I've got 3 times a trinomial, and that trinomial can be factored into 2 binomials. I'm looking for 2 numbers that multiply to, so I've got a is 1, so 1 times negative 33. I'm multiplying to negative 33. I'm going to add up to b, which is 8. So 2 numbers that multiply to negative 33 and add to 8. I've got 11 and negative 3. 11 times negative 3 is negative 33. 11 plus negative 3 is 8. So x plus 11 times x minus 3. Now, there is no value of x that's going to turn this first factor into a 0. It's just always going to be 3. So my 2 solutions are only going to come from these 2 factors. In the second factor here, x plus 11, if I put in a negative 11, I'll get a 0 times 3 times this factor equals 0. And what value of x would make this factor a 0? That's 3. Notice that this 3 that I pulled out actually had no effect on my answer at all. So honestly, I could have just divided both sides by 3 and it would have been gone, and it would have done exactly the same thing. And then on D, once again, I look for what I can pull out of all 3 terms. And in this case, unfortunately, I don't see anything, so I've just got to factor it as it is. And here we are now factoring with a Lie coefficient other than 1. Okay, so I like to do this using the box method. You may know other methods, and that's fine. I like the box method, so that's the way we're going to do this here. So my number that I need to multiply to is A times C, 15 times negative 14. And 15 times negative 14 is negative 210. I'm adding to B, which is 11. Okay, so two numbers that multiply to negative 210 and add to 11. I'm thinking 21 and negative 10. So 21 plus negative 10 is 11. 21 times negative 10 is negative 210. So that original trinomial, I'm going to split the b up. So it's 15x squared plus 21x minus 10x, which is 11x. So 21x minus 10x is 11x. Minus 14 equals 0. So I haven't changed any values. I just took that 11 and split it up into a 21 minus 10. Or a negative 10 plus 21. The order here between these middle two does not matter at all. Okay, so now I'm going to put that into a box. My first term always goes in the first box, 15x squared. My last term, the minus 14, always goes in the last box. The other two terms, it really doesn't matter which of these two boxes it goes in. 21x and minus 10x. Okay, so now I'm going to see what can be factored out of each row and each column. So let's start here on the left column. It doesn't matter which one you start with. But 21x and negative 14, I can take a 7 out of both of those. So I'm going to have a 7 right here. And that 7 is next to a positive box, so it's going to stay positive. 15x and negative 10x, I can factor out a 5x. And that's a positive box. My number here is going to stay positive. 15x squared and 21x, I can take out 3x. 3x is next to a positive box, it stays positive. Negative 10x and negative 14, I can take out 2. And that 2 is next to a negative box, so that's actually going to be negative. So my factored form comes from what I see on this side and on the top here. Doesn't matter which order. 5x plus 7 times 3x minus 2 equals 0. So there's my factored form. Then my two solutions are whatever I get for x when I set each of these two factors equal to 0. 5x plus 7 equals 0, and 3x minus 2 equals 0. So I move that 7 over and divide. I get x equals negative 7/5. I move this 2 over and divide. I get positive 2 over 3. Okay, so that is how you solve a quadratic by factoring. In the next video, we will solve by completing the square.